Okay, let's continue. We can also create hexadecimal octal numbers in Python too. And the rule is, remember we have said that if you want to create an octal, that is a 0 and a O. So start your value with a 0 and O, and then Python will know that is an octal value. And similarly, if you want to create a hexadecimal, and then you start from a 0 and X. Okay, so we can try that. Okay, let me delete the content for now. Let me say A equals a 0, O, and then a 10. Okay, so I'm creating a octal value A, and that is 10. Okay, and then if I want to print A, and what do I get? Okay, I got an 8. Why? Because that is an octal value 10. And octal value 10 is indeed 8 here, right? So let me try something else. How about I change it to 11? So now I have a octal value 11. And octal value 11 is a 8 plus 1. That is a 9, right? So in this case, I'm going to print the A and I should get a 9. And yes, I got a 9. So what does this mean? This means I can create a octal value. However, this value will be printed to be a decimal value by default, right? Okay, so let me try something else. How about I create the A to be a 9? Okay, A is a 9. And then the next thing I want to do is, how about I use this trick? That is, I want to use a OCT 64. I'm forcing the decimal value 64 to be an octal value, and then I got 100. So I want to try something like this, but I want to use a smaller number. How about 9? So I want to use OCT parentheses. Okay, so in Python this is called casting. I'm taking the value A and then I'm forcing the value A to be an octal value and then print it out. So let me see. You know 9 in octal, that is 11. So do we get 11? Yes, we do. We got a 0, 0, 11. That is an octal value of 11. Okay, so let me try something else. If I want to do a hex, that is, I want to force the A to be a hexadecimal, what do I get? Do you want to take a guess first? We got a 9 again, but a 0x 9. 0x means that is a hexadecimal, but we still got a 9. Why? Because that is too small. How about we do 19? And if we do 19, and then we are going to have 2 digits in the hexadecimal at least, and that is 13, because that 1 is for 16, and 16 plus a 3 will give you a 19. So 13 is the hexadecimal version of 19. Okay, so this is the trick. If you have a decimal and then you want to force that to be an octal or a hex or binary, well, this is how you can force a data type into another type before you print it out. Okay, so let me come back. Okay, the next thing is dynamic typing, and the dynamic typing is allowed in some of the programming languages, but not all of them. Okay, so that is, well, when we create a variable and then we don't really have a specific data type binded to a variable name. So when we create a variable name and then we first assign a value, right? And then the second point is there's no type information associated to a variable name. So later, if say the variable A is now 10. If later we want the A to be a string called hello, can I do that? In Python you can, but in some of the programming languages, for example like Java, you can't. Okay, so what do I mean? Let me write down the code here. So A is 19, right? So if I want to say A equals hello, okay, so originally A is 19, and then I updated the A's value to hello. So now A is a variable name to a string. Okay, originally A is a variable name to an integer, but later A is a variable name to a string. And then if I want to print A, I should see hello. So is that okay? The answer is yes, in Python it is okay, because the variable name A can be used by a string, it can be used by an integer, it can be used by a float. No problem. Okay, so A is not created specifically to be a variable name only for integer. So that is called dynamic typing. So the next thing, we want to talk more about what happens behind the scene when we create a variable or when we update the value of a variable. So the first, if we do A equals 3, that is, we create a variable named A and then we initialize the value to be 3, right? So the first thing is Python will create an object representing the value 3 or holding the variable 3. And number 2, Python will create a variable named A if the A is not in the naming table yet. So there is no variable name called A, and then Python will create a variable name A, and eventually Python will link the variable name A to the object 3 created. So that is called a reference. So a variable name has the reference to the real value, which is 3 here. Okay? And the next thing, how about we do A equals 3 and B equals A? So A equals 3, so A refers to 3. And then B equals A, so B doesn't point to A, but B will point to A's value 3. So now A and B both have the value to be 3, and they are referring to the same value, the same object 3, right? And how about we update A's value to change? So now A is no longer 3. A has a new value change. How does Python handle that? Python will create a new object change, which is a string, and then Python will update the reference. Now A refers to the string change, and yet B still has the original value, which is 3. Okay, so objects are the allocated memory. So both 3 and the string change stay in the memory. And then for the variables, they are the entries. And then when we are using the variable name A or B, and then Python will find those names and then follow the reference to get really the value behind the scene. Okay, and the next thing is garbage collection. Well, how do we create garbage? Let's consider those 2 lines of code. A equals 3 and then A equals 5. So A equals 3, we got that, and then A equals 5. So A will update the reference to 5, and then how about the value 3? The 3 still stays in memory, right? Because 3 is still an object in your memory. However, there's no variable can really refer to 3 anymore, so 3 becomes a garbage or an orphan in the memory. No one is going to use it, but it takes the memory space. Then what? Then Python, after a while, Python will get rid of the 3 eventually. So this is called garbage collection. And then Python will be able to release some of the memory from your machine. So Python is doing your machine a favor. Okay, so I think that's the final part. So keyboard input. So well, if we want to type something and then we want Python to take that, and it is super simple. We want to do a input and then parentheses. So input parentheses and then code again, and then that is the prompt. Okay, so that is I want to use please enter your name as a prompt, and then the program will stop, and then it will expect the user to type something by themselves. And when they hit enter, and then whatever the user have been typed will be taken to the variable called name. And then if you want to do the age again, and then we do another input, another prompt, and then whatever typed by the user will be the age, and then we print the age. Okay, so anyhow, input will does the work for you, and then use the parentheses and then code a prompt. And if you don't want to do anything on the prompt, and then you do an input and then an empty pair of the parentheses, that's also okay, but usually that's confusing. I highly don't recommend you to do that, because when you run the input without a prompt, the program just stops, and then you don't know why it stops. So it's a little bit confusing. Okay, and another trick we want to do is, well, whenever you take the user input from the keyboard, it will be taken as a string. So it will be taken as a string. However, sometimes we do want to have numbers, right? So if I ask you how old are you, you tell me you are 18, for example. And then I'm going to take this 18, but I'm going to take this 18 as a string, not as an integer. That's not cool. I want to have the value as an integer. How can I do that? Well, just now I say I can force a data from one type to another type, right? So this is called casting, and I can use the casting again. I'm forcing the age from a string to be an integer. Okay, so I can cast the age to an integer. Okay, so I want to stop here, and really I want to grab the code and show you. So let me take those 2 lines of code, and then I do a separator. Okay, and then how old are you? So the problem is, when I grab the code from the lecture notes, sometimes I have to replace the codes. Okay, so yeah, they are fixed. And then if I run that, and it will say, how old are you? But Python is still running. So in this case, I say I'm 35, for example. Okay, I'm not telling you I'm 35, just for example. And then if I hit enter, and then it will print my age, 35. So far, well, this means Python can take my input, and then right away Python just output whatever I just typed. Okay, and then as I say, here is a small problem, because this age is really taken as a string. So I want to do that as an integer. So I want to change it a little bit. I want to say, how old are you? Age. And then I do age int equals int parentheses age. Okay, I want to take the age and then force that to be an integer, and then I create a new variable called age underscore int, and then I print age int. Let me try this again. Again, I'm 35, and then I still get 35. So it seems that this version does exactly the same thing to the last version. But what's the difference? Now I got age as an integer. And why it is cool? Because later I can do age underscore int equals age underscore int plus 1. So I'm increasing my age by 1, and then I can get a 36. Well, because this age int is an integer value, so I'm able to increase the value by 1. Okay, so the next thing. So can we do this with 1 line of code? So those 2 lines, how do we do that with 1 line of code? And the answer is yes, we can really do that. So let me take out this line, and then I can simply do age. Let me change this variable name to age, and then I do a int parentheses. Okay, let me explain. Okay, well, inside the parentheses, I do input how old are you. It will provide the prompt and then take the user's input. And then outside, I do int. So that is, I am forcing whatever the user types to be a int value, and then I print the age. So in this case, the age value itself will be an integer value. So I run this, I still get the same thing, but we should know now the age variable is an integer. Well, is this version cool or not? Well, think about that. Do you like this version? Or let me just show you use the old version and put that side by side. Okay. So I can say age equals, and then age equals int age, and then print age. Okay, so this version and this version, they do exactly the same thing, except for the first version, it saves one line of code. So you can decide if you like this version or not. Sometimes programmers may love this version because it is concise. But personally, if you write this line of code, I have no problem with that. And by the way, the second version could be more readable. Okay? And then if you want to change it to age int, and then you print the age int, that's also okay. Okay, so let's come back to this part. Okay, so the next thing is when we do the age underscore integer, we are using a specific style of the variable naming that is called snake case. The snake case is just lowercase, one lowercase word underscore another lowercase word underscore another lowercase word. And well, in Python, this is the convention in most of the cases, and there is also another style called camel case style. So this is camel case like this. So well, it doesn't matter really what naming style are you using, but personally I recommend you use the snake case style, and that is the more common, just common style for Python community. And if you're doing Java, for example, and then Java community uses the camel case more. Okay, so well, after today's lecture, remember there are 2 CS Circle sections you're able to do, and if you haven't registered a CS Circle account, and you should do that. And next video I'm gonna create will be a introduction video to the in-class exercise. Okay, just one more video to go, and then we are finished today's lecture.